Who invented 3D printing and when? This is popularly attributed to Chuck Hull, the founder of 3D systems. This happened sometime in the 1980s, even before I was born. So 3D printing has been there for quite some time. The other questions we'll see as we go on. What is 3D printing? I'm pretty sure most of you have come across 3D printing one place or the other. In its most simple form, a 3D printer converts some sort of digital file into a physical product. Now, can you think of a one-word answer for this process? Think about it. Manufacturing. So 3D printing is nothing but just another manufacturing technique. How does it work? Think about how we've been building houses for thousands of years. We deposit one layer of material, stones, bricks, concrete, whatever, go up, deposit another layer, and keep doing it until we get the shape we want. Except that in 3D printing, it's all computer controlled. Since we are adding one layer upon another, 3D printing is technically called additive manufacturing. We are adding one upon another. Now, the concept of manufacturing is not new. Let's look at a few other manufacturing techniques. Number one, injection molding, a very popular technique for plastics. You see this huge setup, they are the molds. Molten plastic is injected into the gap between them, the red colored one. Once the plastic cools, the molds are pulled apart and the part is ready. Number two, casting. A similar setup but usually done for metal parts. Number three, let's say material is pressed or bent into shapes. That's called forming. Example, car bodies are made this way. Number four, CNC routing. A traditional method of removing unnecessary material from a huge block. It's pretty much how we've sculpted rock for thousands of years. This is classic subtractive manufacturing, the opposite of what we are about to learn. Now, these techniques are all pretty mature compared to 3D printing. They do work flawlessly. In that case, why do we need a new technique called 3D printing? When I ask this, the most common answers I get are cheaper, more accurate, no material wastage. I can actually argue that all the mature technologies we saw can pull these off. For example, injection molding or forming, cheap, accurate, no wastage. So think again, what's so unique about 3D printing? Let me give a slightly different perspective. Any new technology to take over an existing one, there are only three possibilities. The new one is way too cheap or way too fast, or it does something the older one cannot. The same goes with 3D printing, but there are very specific scenarios where this makes sense. You have to adapt 3D printing only in those. Number one, cost. There are two graphs in this. The first one starts at 400 and then goes all the way down to 10. This indicates the cost of some random part with traditional manufacturing. When quantity increases, the cost drops, which brings us to the problem. Low quantity manufacturing is super expensive. Let's take an example. MI sells this camera for about 2000 rupees. The plastic on this would have costed hardly 1 rupee. Let's say I want to make only one unit of this. If I create a setup for injection molding, that whole tooling process, the cost would be probably about 5 lakhs or so. So my effective cost is 5 lakhs plus 1 rupee. If I make two pieces of this using the same setup, then the cost gets split. So 2.5 lakhs for the setup plus 1 rupee each for the material. If I make 5 lakh units, setup cost is only 1 rupee each. At scale, the traditional manufacturing technique makes sense, but not at low quantity. Now, can we 3D print this whole chassis for just 1 or 2 rupees? Impossible. Probably a few hundreds. That's the second graph. 44, 43, 42. It keeps going. Since there's no setup cost that gets split, the cost remains constant. The interesting factor is this blue dot. Beyond a certain quantity, 3D printing becomes more expensive than traditional manufacturing. So to be very specific, 3D printing solves the cost problem only when the quantity is low. Another factor that you have to look out for is this blue dot. This keeps increasing every year. In 2022, this is somewhere close to 1000. What that means is if you're trying to manufacture 1000 units and above, traditional manufacturing may be a bit cheaper. If you're trying to manufacture 1000 units and lower, additive manufacturing, 3D printing, and its allied technologies may make it more economic. Number two, speed. When the pandemic hit the world in March 2020, that's when it became more widespread. Some European designers came up with the idea to 3D print a simple frame, attach a transparent sheet, and wear it to prevent the virus from entering your nose or mouth. The idea of a simple face shield was born. Now, in less than 1 week, people all over the world started 3D printing these. This was probably the only non-digital thing that got global adoption so fast. So what I'm saying is, once there's an idea, all it takes is literally the design time and the printing time. There's no better way to manufacture something so fast. Look at this tab. What's so special about it? Water flows through these spiral holes. Such holes cannot be created with any previous technologies. The only way this can be made is by 3D printing. Now, this is made by American standard. This is a piece of art 3D printed in titanium. They sell it for somewhere around $20,000. So 3D printing is enabling previously impossible geometries. Number four, let's say we are not on this planet anymore. If we need a small part, should we ask the humans on Earth to send a rocket up with your part? Doesn't make sense. So that's the 3D printer on the ISS. Simply explains or says make anything anywhere, right? So when we land on the moon or Mars, we'll just be deploying large 3D printers to make whatever we want, buildings, parts, food. Again, make anything anywhere. Now, we've shipped out 3D printers somewhere in the Himalayas, somewhere on the ocean, on ships floating, where they're making 3D parts on the fly. So, summing it up, cost, speed, uniqueness, and accessibility are why 3D printing stands out. On a secondary level, if you have 3D printing in your production line, you can update your production line without any major changes, because you're just pushing your new file into the 3D printer, and your 3D printer all of a sudden starts making new parts. Another advantage, you don't need a huge factory setup to create parts, but rather a small desktop setup starting only 60 watts. So your energy consumption is very, very less. Risk reduction is on two levels. Economic, because no huge investments are going into manufacturing. And number two, your IP stays intellectual property. It stays between you and your 3D printer. There's no chance of leaking out. So that's one risk reduced as well. So these are the advantages of 3D printing.